Hey, good afternoon, everybody. So excited to get this Devcon started with you and to talk about this EIP-7702. Before we get into the technical deep dive, I was just curious, who saw this headline from Coindesk? This was how we introduced 7702 to the world. 22 minutes of Vitalik writing the PR for the EIP. But it really started from this future of EOA AA breakout call. We were kind of having some deadlock with the wallet developers in the community and the client developers getting an agreement about what exactly should happen with the Prague hard fork with respect to account abstraction. And in this Telegram group, this AA Mafia Telegram group that some of you are probably aware, there was a bit of discussion with Vitalik about what we need to do. And right before the breakout room, he had a breakthrough. And he was scrambling to write the pull request for this EIP and ended up taking about 22 minutes to write this first proposal. But that's only part of the story. So obviously, these ideas happened through many months and years beforehand, and we've been working on 3074 for a couple years. And these ideas are not new. There's been commentary that maybe 7702 is being rushed to the main stage for Ethereum, but I don't really think this is the case. This is something that's really encapsulating a bunch of ideas that we've had with 3074 over the years, and now we finally found the right way to package it together to give the best interaction with wallet developers, client developers, and generally what we want Ethereum to look like in the future. So with that said, that's some prehistory for 7702. Let's jump into the actual technical details about how this EIP works. I think most people in the room probably understand the motivation for the EIP, so we can kind of skip over it. But I do want to mention this bootstrapping phase, because this is kind of something that is a big differentiator between the prehistory, this 3074 history, and the world with 7702. So with 3074, we had this idea that we wanted to make EOAs as generic as possible and let them do any kind of execution that you can imagine, so long as they provide a signature to authorize the execution. With 7702, we tried to take a bit of a step back, and this was really the breakthrough between 3074 and 7702. We wanted to allow EOAs to have the power that they deserve to have, but we wanted to try and push users in a direction of using smart contract wallets. And we felt that this was an important phase of bootstrapping the smart contract wallet community, where instead of having to choose, is your app going to natively support EOAs great, or smart contract wallets great, you get the opportunity to have a unified interface across both EOAs and the smart contract wallets. So how can we do this? How can we create this environment for users? Well, if we recall, this is what an account in Ethereum looks like. You have your nonce, balance, code, and your storage root. What we want to do is we want to take smart contract wallet code and we want to put it into the EOA accounts. How is this possible? This is really what 7702 provides. We're introducing a new transaction type, the setcode transaction type. And the way the setcode transaction type works is it's extremely similar to how the 1559 transaction type works with this additional authorization list element. And inside the authorization list, you have your authorization, which is basically saying, as an EOA, that you would authorize some code to live into your account. In the authorization, there's the 4 elements. We have the chain ID. The chain ID is just saying, I authorize this account, this address, to act on behalf of my account on this chain. The address is the address of the account which you're authorizing to act on your behalf. What do we mean by this? This is this idea called creation by template. And it's a bit different than how you deploy contracts today on Ethereum. Unlike the init code deployment that most of you are probably used to, where you return the code that you want to exist in the account at the end of the init code, you actually say just immediately what the target that you would like to be put into the account is. So instead of running this initialization phase, you actually have the initialization via regular call later on in the transaction. Why do we do this? A big reason is that we wanted to minimize the amount of call data from trying to migrate your EOA into a smart contract wallet. And what we found is that you have to say what target code you want to execute in your account. It's not as simple as providing just the 20 bytes today, because typically you have to provide the 20 bytes for where the template is going to live, and then you need to have some setup code around this to Xcode copy the data, bring it into your account, return it from your init code. And we found that having this extra amount of data just moving bytes around Ethereum was pretty much unnecessary. And we wanted to focus on just providing the address which the code would be pulled from. We also feel that this minimizes the chance that users are going to change their delegations regularly. Like I said in this bootstrapping phase, we think it's really important that we get users focused on using smart contract wallets and not trying to create different types of UX in Ethereum where they have maybe ephemeral delegations that only last short periods of time. Now, creation by template, as I'm describing, is basically saying, take this address and put the code at that address into my account. This doesn't quite work today because we have an EIP-7607, and what it says is that if you have code in your account, it's not possible for you to originate transactions. So we need a way to work around this. And how do we do this? This is basically the idea of what is going to go into your account. So after you submit a 7702 transaction with your authorization, you'll end up with a delegation designator into your account. And this designator is a structured piece of bytecode. It's 23 bytes, and it starts like this. You have the first byte, this EF byte. This comes from the EIP-7541, and we've had this in several hard forks ago with the idea of creating a special domain space of account code that users could not deploy to. So today it's not possible to actually deploy a contract that starts with the byte EF. And you might be familiar with why this EF byte came from. Originally we have this idea in the future to have the Ethereum object format, EOF. And this will create a new space for EOF contracts to live where there's been some validation done to the accounts beforehand. What 7702 does is it builds on top of that idea, and so it adds a few more discriminator bytes to say, this is a 7702 delegation designator, and at the end you have your target address, the remaining 20 bytes. So you can think of this pictorially as having a pointer in your account that says, the code from my account should be loaded from another account, and the other account that we're thinking of in this case would be some kind of smart contract wallet. Okay, so that's the chain ID and address. We've got the nonce and signature. The nonce is just going to be the nonce of your EOA, and the signature will be a signature from your EOA, just providing replay protection and some authentication from your account that you actually do want to set a delegation to your account. Perfect. I don't know if you guys can all read this in the back, but let's dive a little bit deeper into exactly how 7702 works. We can think of this function, process authorization, as something that lives between checking that the transaction is valid and before the EVM execution for your transaction happens. What we do is for every authorization that exists in the authorization list, we first check that the chain ID is either not equal to the chain ID of the chain, or we verify that the chain ID is not 0. So there's an additional opportunity for 7702 authorizations to say if the chain ID is 0, it's valid on all chains, similar to today with transaction signatures. One thing that might be confusing about the way that we process the authorization list is you can notice that there's a continue here, rather than raising an error or returning a fault. The reason that we do this is that we're trying to avoid very complex interdependencies of transactions. Because the transaction type is relying on the nonce of the EOA, you could imagine that you have a transaction that has many different EOAs within its authorization list that could possibly invalidate many other transactions that are pending from those accounts. So what we've done here is we've kind of tried to keep the transaction validity simple, focusing only on the overarching sender of the set transaction format, the set transaction object, rather than creating this dependency level. And we feel that this avoids any kind of denial of service attacks that users might be able to come up with. So after you verify your nonce, we'll recover the authority from the signature that's in the authorization. If there's any kind of issue recovering it, we continue on. Then we check the code for the authority. Here we check to see, is there any code deployed in that account? Because if there's code deployed into the account, we need to retain the property from EIP-7607, where we don't allow the EOA to originate a transaction. So after we do that, we also need to make sure that if there is code, that the code is a delegation, because we want users to be able to replace their delegation. We don't want users to forever and always have a single delegation that they've chosen. So you have this opportunity to update your delegation. After that, we do the nonce verification, and if it's correct, bump the nonce. And then finally, we actually make the delegation designator that you saw on the previous slide. This is written into the account, and now you have your delegation designator, so all of the operations will load the code that you're pointing to. There's also an additional short-circuiting mechanism here that we've done. And instead of writing the actual 0 address, if you pass that as an authorization address, we will completely clear the delegation designator from your account. And the reason that we do this is we found we want to allow users the opportunity to completely undo the delegation operation. That way, after you submit this operation, it's basically impossible to tell that your EOA was ever delegated to another account, just to make users feel more comfortable with trying this new mechanism. I want to try and wrap all of these technical concepts into maybe a more clear example. So imagine you have some user, and the user has a thought. Gee, it would be super nice if I had a smart contract wallet, because today, my account just looks like this. No code, empty storage root. I can't do any kind of interesting things like batch my transactions or have someone else pay for the gas for my transactions. What they can do now with the prog hard fork after 7702 is they can sign an authorization. And this authorization will basically say, on chain ID 1, the mainnet, I would like to authorize the address A94F to act on my behalf. And they've signed the nonce for replay protection and the signature that says that they authorize this thing. What you'll notice is that they have a balance of 0. And as you saw before, with the setcode transaction, we have to wrap the authorization to send it onto the chain. But with an ETH balance of 0, they can't actually put this authorization on chain themselves. So what they need is they need another party to help them. And so in this case, they'll find some sort of bundler who can help them put their authorization on chain. So they send the authorization to the bundler takes it, puts it inside of a setcode transaction, and then the bundler can actually send it to the chain. So this gets processed, the user's account is updated, their nonce is bumped, they still have a 0 ether balance, and the code is set. So they have their delegation designator. And you would probably think that we're done, but if you remember when I mentioned you still have to initialize the account, and it doesn't happen during the normal init code, what they now need to do is they need to call their account with some initialization data. So they can do this with the same builder in the same transaction in a different transaction. It's not some type of atomic operation. They can do it at any point later on. So they'll pass this call data in, and they'll basically say, I want to set the owner of my smart contract wallet to maybe the same key as my EOA or a different key as my EOA, or maybe I want to delegate some different types of keys to my account. I want to give it a pass key for my phone that can spend only $100 a day. You have the opportunity to initialize however you want. But you have to sign over this data because this is how you convince the account that you have the authority to update what the owners are. So this call is sent to the account, it's processed, and then we update the storage root, and now the account has an owner. They can continue using the bundler, they can add some ETH to their account, they can batch and do whatever kind of smart contract wallet operations that they would really like to do. So we kind of glazed over what the gas costs of this thing are, but since this is a technical deep dive, I do want to kind of go over them a little bit. The intrinsic cost is extended to charge 25,000 gas per authorization in the authorization list. And if the account is already existing in the try, we will refund 12,500 gas. So you can really think of the cost of an authorization as 12,500 gas rather than 25,000. But the 25,000 gas comes from the creation of new accounts in the try. This happens if you send Ether to an account that doesn't exist. You have to pay this 25,000 gas to create that account in the try. You have to do it when you create an account. So what we do is we refund it if the account already exists, but it is subject to the global refund counter. So if you get a 12,500 gas refund, you have to spend 60,000 gas, otherwise you're capped at the 20%. If you need to get a refund of 2,500 gas, you have to spend 120,000 gas to get the refund. So it's not always in exactly 12,500, but we expect most of the time it will be. The other gas cost to keep in mind is that we extend the convenience warming of an account to also include the target of your delegation. So if you're sending a transaction to an account which has a 7702 delegation designation, what we'll do is we'll also warm the account that the delegation is pointing to. This is just a convenience warming. It's an extension of sort of what has already existed. What we don't extend is a convenience is during EVM execution. Anytime you make a call to an account that has that delegation designation, you do need to warn the account that you called and the account that the delegation is pointing to, if either of them happen to be cold. So that's kind of the summary of the technical summary. If there's anything to take away from this talk, if it was kind of more high level or more low level than you expected, in early 2025, you're going to be able to put smart contract wallet code into your account. So the next things that are going to happen with 7702, there's a ton of events this week around 7702 and account abstraction. I think it would be amazing to continue collaborating with all of the builders that are thinking about how to bring this to the user, how to bring this to the masses. And so experiment, try some of these rolling dev nets that we have. We have a rolling dev net with the ETH DevOps team throughout this week. Ithaca has their experiment 001 to try 702. And check out what the application, how the application standards are evolving. There's a lot of opportunities right now to figure out a cohesive user experience for dApp developers, wallet developers, and users so that we can all use the same platform and not create a bunch of fragmentation around the new possibilities that exist in accounts. So that's the technical deep dive for 7702. Happy to take any questions now.
Testing. Thank you, thank you. We have a lot of questions. So again, if you'd like to vote for ones you want to see answered, there are a bunch here and we will go from most voted down. So we're gonna start with, why do we still need ERC 4337 after EIP 7702?
Yep, so I kind of pointed out to this in the diagram where you have this bundler that you're just kind of sending the authorizations to and they're relaying some calls onto the chain. 7702 doesn't describe how any of these things happen. And this is like what 4337 does in a lot of ways. Like it sort of describes how you get an operation from an account that has no gas and you relay it on chain in a safe way. Additionally, with 7702, you always are going to have the EOA key that controls the account. And so if you think about it in terms of like a privilege de-escalation sense, you always have a key that has complete control. And if that's something that you don't feel is right for your security model, if you feel like the only way to control your account needs to be with a multi-signature, you're gonna have to use 4337 to do that.
Awesome. We will get on to the next one. Sorry, did that work on your side? We're gonna start with, can the chain ID be set to 0 to authorize all chains?
Yes, the chain ID can be set to 0 to authorize all chains, but it is important to note that because the authorization has the nonce in it, it's not necessarily the case that every single chain has the exact same nonce on it. So you have to keep this in mind when you're thinking about creating a multi-chain authorization.
And then so EIP 7702 makes address space extensions obsolete?
I don't think so at all. The reason that we have the 7702 type bytes in the delegation designator is it's 0100. So in the case that we in the future have address space extension, it's extremely simple to just say we're going to bump the version of the 7702 prefix bytes to say the next 32 bytes are the address rather than the next 20 bytes.
Sorry, I'm having my moment here, but we'll start with, I guess we're going to go just what's there. So EOA revocation is required for post-quantumness. Is it specified?
This isn't really specified by 7702 in any way. We're kind of just extending the functionality of the quantum insecure EOAs that exist. That's kind of future work to be done.
How does the signer of the auth guarantees the initialization call is correct, risk of front running?
I don't really see I don't see that there's a lot of risk of front running if you are authorizing to an account that is expecting this type of initialization. In the diagram, I was kind of trying to point to this and allude to this where you have a call, and it's not a typical call because in the EVM usually you use the message.sender as the authority of things. But because in this type of initialization of account, you might want to be bundling the initialization through a bundler and you can't rely on message.sender. So you have to verify the signature from the EOA, and this sort of gives you that trust to initialize the account in a way that can't be front run by someone else, because only you can control the private key that you're creating the delegation for.
Sorry, I'm having my is not filtering on my phone, so we're gonna go next with how would 7702 work in stateless when there is no longer a state root?
I don't see why there's going to be much problem with it.
And then how does it compare to EIP-7806?
So 5806 was kind of a precursor for some of these ideas with making EOAs better. I generally felt that 5806, for those who don't know, is kind of this idea of executing code on behalf of your EOA, but in like an ephemeral way. So the transaction, there might be some code data in it that says, you know, execute this snippet with my account. And this provided some of those functionalities like batching, but it didn't really provide some of the functionalities that we wanted around privilege de-escalation or gas sponsorship.
We're like speed answering these at this point. Can you do recursive delegation?
You cannot do recursive delegation. Basically, if you try to delegate to an account that delegates to account, the EIP specifies that you just immediately stop after the first delegation when resolving.